Welcome to This Explainer. Look, if you've ever felt completely overwhelmed by the sheer scale of modern data ecosystems, well, you're definitely in the right place. Today, we are going to demystify big data infrastructure. And to make it really intuitive, we're going to design a complete architecture from the ground up by treating it exactly like constructing a highly secure, modern skyscraper. Let's get into it.
Here is our architectural blueprint for the explainer. We're breaking this massive topic down into 5 highly logical phases. First, the foundations of data. Second, storage, warehouses, and lakes. Third, platforms and design architectures. Fourth, governance, privacy, and security. And finally, modernizing with MLOps and mesh.
All right, phase 1, the foundations of data, building the base. Because before pouring any concrete or, writing code or spinning up servers, we have to define exactly what it is we're building this massive structure to manage. So here's the crucial point. Big data isn't just a lot of data. It's fundamentally different. We're talking about data sets so extremely large and complex that they literally break traditional older relational database systems. You simply can't just open these files on a standard computer or process them with a legacy SQL server. It just won't work. The structural integrity of our entire system rests on managing what we call the 3 Vs. First up, volume. We're talking massive, petabyte-scale amounts of data generated every single day. Next is variety. It's no longer just neat little rows and columns. It's unstructured text, video files, sensor logs, you name it. And third, velocity. The incredibly high speed at which this data is generated and actually needs to be processed. And mastering those 3 Vs is absolutely crucial. Notice how massive inputs from IoT sensor networks, social media platforms, and e-commerce transactions all pour into the system. Capturing that effectively, well, that translates directly into better decision-making, predictive analytics, and real-time insights for the business. That is why we build the skyscraper. Moving on to phase 2, storage, warehouses, and lakes, constructing the vaults. Now that our foundation is set, and we actually know the sheer scale of what we're handling, we need to build the vaults to hold it all. Which brings us to the most basic, but honestly most daunting question in big data. Where exactly do we securely, affordably, and efficiently put all this information? I mean, if we just dump it in a giant pile, it's completely useless. To solve this, we generally build 2 very different types of vaults. On one side, we have data warehouses. Think of these as highly structured, organized repositories designed for clean historical reporting. On the other side, we have data lakes. These are massive, super flexible repositories designed to hold raw, unstructured, and semi-structured data exactly as it arrives. Looking at these concepts side by side, notice how the data warehouse uses a rigorous ETL process, extract, transform, load, to cleanly organize data for business analysts. Contrast that with a data lake, which just ingests everything raw in a schema-on-read approach, making it absolutely perfect for data scientists and AI. Oh, and today, organizations are increasingly combining the reliability of the warehouse with the flexibility of the lake to form what's known as a modern lakehouse architecture. It's the best of both worlds, really. All right, phase 3, platforms and design architectures, the engine room. With our vaults completely constructed and holding our data safely, it is time to build the engine room. This is where the real heavy lifting happens. Think of the overarching big data ecosystem as our central engine. Within it, you have technologies like Apache Hadoop and Apache Spark acting as our primary processing engines. They connect directly to our storage vaults like HDFS or cloud data lakes to perform distributed, scalable computing. Essentially, instead of relying on one massive supercomputer, they cleverly break the work down across thousands of smaller machines. To process data effectively without totally overloading the system, our engines run on 2 distinct flows. The first is batch processing. This handles massive historical datasets, often running overnight to process everything that happened that day. The second flow is real-time streaming. This processes continuous streams of data the exact millisecond they happen, using tools like Apache Kafka. Now, what's really interesting here is the Lambda architecture. It ingeniously solves the dilemma of choosing between those 2 flows. It essentially splits the incoming data, sending it through a heavy-duty batch layer for comprehensive accuracy, while simultaneously sending it through a speed layer for real-time streaming. This gives end users incredibly fast, highly reliable analytics. Phase 4, governance, privacy, and security. This security system. Because let's be real, a state-of-the-art skyscraper is absolutely useless if anyone can just walk right in and take what they want. Let's install our security system.
The entire core of our security philosophy is built around the CIA triad. And no, actually, not the government agency. It stands for protecting the confidentiality, the integrity, and the availability of our data. We absolutely must guarantee that our data remains strictly confidential, perfectly accurate and unaltered, and always available to authorized users when they need it.
We enforce this triad using several critical layers of defense. First up, strict encryption for data both at rest and in transit. Then, we implement rigorous access controls and authentication to ensure only the right people get in. And finally, we rely on constant automated monitoring and auditing to detect anomalies and stop data breaches before they even happen.
But hey, security isn't just about locking doors. It's also about knowing exactly what's inside the building. That is why we implement a data catalog. Think of this as a centralized master directory that uses metadata to map out everything we have. It lets our analysts, engineers, and scientists easily search for, trust, and collaborate on the data they need, while automatically enforcing strict governance policies.
And overseeing all of this internal security are external legal frameworks like the GDPR. With big data, you're often handling sensitive personal information, right? So frameworks like the GDPR mandate that we enforce stronger privacy controls, practice data minimization, and manage personal data in a way that is lawful, fair, and completely transparent to the user.
Finally, Phase 5, modernizing with MLOps and mesh, the smart innovations. The structure is built, it's secured, and it's running. Now we upgrade it with smart innovations to automate operations and safely decentralize control. If we want to run advanced machine learning in our skyscraper, we definitely can't do it manually. We need MLOps. This is a continuous automated lifecycle. It flows systematically from initial data ingestion straight through to model training, pushing to deployment, real-time monitoring, and using version control to constantly improve the models without any human bottlenecks. This intersection is exactly what we're aiming for. By officially combining machine learning practices with DevOps efficiency and solid data engineering, organizations achieve vastly faster deployment times and incredibly reliable, scalable AI operations. It completely takes the guesswork out of deploying AI at scale. And to top it all off, to prevent a centralized IT department from becoming a massive bottleneck as our building scales, modern architectures introduce the data mesh. Instead of hoarding all the data in one central team, the data mesh decentralizes it. It actually empowers specific domain teams, like sales, finance, or marketing, to completely own, manage, and serve their specific data to the rest of the company as a high-quality product. So, stepping back to look at our completed architectural blueprint, from our foundational vaults up through the processing engines, all protected by rigorous governance and smart automation, the ultimate question to leave you with today is this. Is your organization still treating data as an unwieldy, chaotic byproduct, or are you actively engineering it as a scalable, secure, and incredibly valuable product? Thanks for joining me on this explainer, and I really hope this provided a rock-solid foundation for your understanding of big data infrastructure. Catch you next time.